All right, so let me start. I'm really happy to be here in Singapore at Wisdom, and my name is Dmitry Stalov. I work at Toloka, and I'm leading research, education, and open source teams there. And I'm really happy to tell you about the challenge we hosted here at Wisdom Cup. It's called Visual Question Answering Task, and it was all about crowdsourcing and all about improving the state of the art in a very difficult task, and I really like how it worked. So before I start, I have to learn how to use this computer. I managed to do it. So before I start, I have to explain what Toloka is and why we are doing this. So Toloka is a data labeling company that turned currently into a kind of machine learning operations solutions that features not just data labeling aspect of machine learning, but we also offer the entire MLOps pipeline. So besides the data labeling, you have models, you have data sets, you have endpoints for APIs and so on. And it's all kind of connected with the data labeling and annotation. But initially, we have been doing a lot of crowdsourcing stuff. And for me, it's very exciting to always benchmark information retrieval systems, machine learning systems, and NLP systems. Basically, I have a PhD in NLP, and I'm always interested in how to do something that current methods don't do really well. And there is a paradox called Moravic's paradox, saying that you cannot really easily give the machine the problem that 1-year-old child does really well. So children are very well at doing something simple, and these simple operations cannot easily be transformed into some algorithmic forms. And it's comparatively easy to make computers exhibit adult-level performance, and difficult or impossible to give them the skills of a 1-year-old. It's still true. And here's our challenge. It's all about this. So we run a visual question answering challenge, and right now I'll explain the task formulation. So how it works. Our task. Some background. So right now we have a tremendous progress in language models. So right now language models do a very well classification tasks using few-shot classification or something like this. They do ingest and they do represent some knowledge about the real world. They are somewhat good at common sense reasoning, and we also have some remarkable progress recently in computer vision tasks. But generally, computers are not very good at understanding humans, on one hand. They don't do very well the things called intuitive physics, because intuitive physics just work. It's not always represented in books or in videos. So, and machines are not very creative, because all these stable diffusion models or language models are just replicating what was already published. And that's a very interesting legal aspect, but it's not what we are talking about today. And our task is this. It's very easy for humans. Any of you will do it very well, but it's not very easy for the machines. And the task is this. So you have a photo, and given the photo and the question in English, there is a question in the blue rectangle. You have to draw a bounding box, so a rectangle, that contains the object answering this question. So it's that simple. So we have the image, we have the sentence, the question, and we have to draw the bounding box. And if you look at this specific example, you'll see that for this image, so we have a person with a racket on some sports place. And if the question is what you will use to hit the ball, so there's the ball, there's the racket, and the answer is the racket. So, so this person would use racket to hit the ball. So that's the core idea of our competition. We have to build the system that draws bounding boxes based on the images and questions, and all in English language. And the key challenge for us in running this challenge was building the data set. And the data set was built like that. So to make this competition a success in terms of data, we needed the images, we needed the rectangles, and we needed the questions. So 3 components. And initially, we explored multiple options, and we eventually we decided to use a very well-known data set from computer vision called Microsoft Common Objects in Context. This data set contained many images, but the good part is they are part of this data set are available under very permissive licenses like Creative Commons attribution. So you just refer to the source and you can reuse them quite freely. And also Common Objects in Context, or COCO, has some annotation. It has classes, it has image segmentations and so on. We did not use it, but we made sure that our bounding boxes do not overlap with the segmentations available in this dataset. So we picked this dataset because mostly due to its popularity, people know it quite well. It's available on most dataset storages, and you can use pre-trained models to achieve some reasonable results because many people run and build pre-trained models on this dataset. Okay, so now we have the images. We have to build questions, and we have to draw bounding boxes for the ground truth data. And to do it, we run a large-scale annotation campaign on Toloka. It's a crowdsourcing platform. We have some expertise in crowdsourcing, and after a few iterations, we found the following approach to be very good. So first, we asked the annotators to look at the picture and draw a bounding box around some interesting object. So they have to look at the picture. They don't have any questions. They just have their intuition. And we were asking people to draw bounding boxes on images. After that, when we get the bounding boxes, we ask people to look at these bounding boxes. The people might be different. It doesn't really matter at this moment. And they drew, they have the image, they have a bounding box, they draw, they composed a question to this bounding box, like what will I do for this, that, and so on. And just to verify that the questions do make sense, we ask them to take a look at the image, at the bounding box and the question, and just to draw the bounding box, and then we draw, then we evaluated if the bounding box drawn by the person matched the ground truth bounding box with some kind of soft criterion. So that allows us to build a data set of 50,000 objects. So here are the examples. So what do you do for cutting? So there are skissers, and there are big skissers in this photo. And what do we use to support the immune system and get vitamin C? So there's a pack of orange juice and all these bounding boxes, and questions were invented by crowd annotators, which is very cool to see. All right, so what we have done then? We had a data set of roughly 50,000 objects. And this data set was split in 3 parts. The first part is called train. So it's the largest part. It has most of the images, and it was available since day 1. So we released the entire train data set with bounding boxes, images, and questions from the day 1 of the competition. And then we had this trick. So we split smaller amounts of data in 2 parts. The one part is called test public, and another one is test private. And we use them in competition. I will discuss this a bit later. So, but basically the train dataset was available on the time. The test public was available during most of the time, but without ground truth bounding boxes. And the private part was not available. It was used internally, but all the datasets were frozen and finalized before we ran the competition. So we didn't change anything during the competition course. How did it work? So here is our competition timeline. It worked like this. So we started in September 2022. We used Codalab, which is an amazing platform to host a competition. And here's the link to the page at the Toloka website for this competition. But we have kind of 4 phases. The first phase is called practice. So when we started, we released a subset of the trained data of 1,000 objects to let people prototype. Then we run the classical evaluation part, in which you submit responses to the leaderboard. And then we had the reproduction and post-competition parts I will discuss very, very soon. So for the practice, we wanted people to prototype. We wanted people to get used to the format, to the task, and so on. So we took a random 1,000 objects from our dataset. We just released them, and we designed a special phase of our competition in which they can predict the already well-known bounded boxes, just to make sure that their code will work on the later stages of the competition. And it was in September. Then we ran the main phase of the competition called evaluation. It was from September to December. And during this part, you have a leaderboard. We had a leaderboard, and for that, and people were provided with a public test dataset. They downloaded it. They wrote a system that predicts the bounding boxes. They submit the responses. By responses, I mean the guessed bounding boxes, the predicted bounding box, to our system, to Codalab, and it printed the results and it put the line to the leaderboard. But that's not enough to actually determine the winner, because you can exploit some leaks in data. You can be using some additional things that might affect the results. So we run another part of our competition on the private test dataset that was not available to anyone at the moment. But that moment is called reproduction. So we had 48 participants, and we asked everyone to submit their code in the form of a Docker container to us, and we had roughly 1 month to run everything on our own virtual machines. It's a pretty beefy virtual machine with the NVIDIA A100 GPU and so on. So we took every Docker container submitted by every participant, decided to do that. We ran the code, and we got the predictions that formed the final standings. And only 9 teams participated in this. So we got the final leaderboard of 9 teams that were not matching exactly the original standings of 48 teams. So, and just to make sure that people can prototype and play with our data after the competition ended, we just ran and made available another phase called post-competition. We released all the data sets, including the test private, and this data set is now available, and you can submit your solutions used on this data set, and you'll get the same results as you will obtain before. So that's how it works. So what were our baselines and evaluation criteria? And the evaluation criterion was intersection over union, or the Jacquard index. So it's just the area of overlap and area of union. So we have the ground truth bounding box, we have the solution bounding box. For one image, we just compute this number. So we measure the area of overlap, we divide it over the area of union. And we had two baselines. And to provide the single number for the entire dataset, we just put the average IO over the dataset. And we had 2 baselines. One baseline is called machine learning baseline. It's a very straightforward application of 2 popular machine learning techniques. The first one is called YOLO-R. It's an object detection method that takes the image and it outputs a set of bounding boxes containing images that it knows how to detect. So people, some machines, vehicles, whatever. So it given an image, it offers you the set of bounding boxes. Okay, so we have many bounding boxes, but we need to select one answering the question. And to do it, we use the OpenAI clip that computes embeddings for texts and images, and we just compute the similarity between the question embedding and the bounding box embedding. So we try to find the closest bounding box to the embedding of the question, and that was our baseline. So it's like YOLO-R plus clip. So it was available to all the participants in advance, so they can build upon it if they wanted, and it allowed us to make it kind of a starter kit. As another baseline, and I'm a big fan of these things, personally, we use the crowdsourcing baseline. So we just get it very straightforward. We took the same task and we asked the crowd annotators to look at the image, look at the question, and select the bounding box, draw a bounding box. So that's how a non-expert human annotator will do the same task. And so given the image in question, you draw a bounding box. That's our crowdsourcing or human baseline. Here are the results. And I don't have a proper speaker here, so but let's do it. So we had 48 participants, 9 of which participated in the production stage. And I would say we have the following results. I think solemn music should play here. I don't have a proper speaker here, so it should be very, very, very motivating. But the results are this. So here are the last 6 teams. So it's ranked 4 till 9. And these are the intersection or union values obtained on the private test subsets of the data. So we have that the criteria span from 75% till like 61%. And let's see what happened when we show the higher positions. So number 3, the third ranked team got 75, almost 76. The second ranked team got it 76. And the winner got it 76. Well, I think it's roughly 1 image or something like this. But generally, it's different. It was different. You might ask me, all right, so we have some team standings, and I really appreciate how these teams did. It was an amazing result. I'm really happy about that. I really appreciate it. Let's see how were our baselines. Let's look at our baselines. And here is our machine learning baseline. So it got 20. So the teams managed to dramatically improve our pretty smart baseline. So Clip and YOLO are pretty difficult, pretty complex models, and people managed to increase the quality over 3 times. That's very impressive. I'm really happy to see that. But if you add the missing line, what do you think? Well, where will be the humans here? On top. And none of the participants managed to beat our human baseline. So that's a good news for all of us, right? So we are still relevant. Yeah, but nevertheless, all the teams did a great job at engineering, at inventing new methods, at discussing it. And I'm super happy to see this. And honestly, I'm also happy to see the green line, but that's my personal preference. I really like crowdsourcing. And the overall result is the humans won the competition. So regardless of what part of the table you are, the humans won the competition. And that's good news. And the top 3 ranked teams received the Wisdom Cup prize, for sure. That was a very well done work. We are really happy about that, and we are really grateful to them. And yeah, congratulations everyone. It was a great job did by a lot of people, including the Wisdom team, including the Toloka team, Quadalab team, many people, the participants, everyone was doing fantastic things. And to wrap up, so crowdsourcing allowed us to build a very challenging competition for machine learning methods. So right now we are not at human level performance on this particular task, which is kind of warming for me. And we at Toloka used our expertise to build this task, and it was a great experience overall. So we can do it, and we will do it more. And we enjoyed the Wisdom Cup very much. So we had almost 48 teams participate in the competition, and 9 participate in the more engineering intensive production stage, because it's not enough to create a method. You need to wrap it as a kind of working solution, and it's not always easy, especially if you are focused on writing kind of some Python notebooks that can be run on your own machine. So making your code and your solution makes another person's machine is a very difficult task, especially for researchers, and I am really happy that people managed to do it. And we thank to everyone involved. And the last thing, as I said before, we created a data set of 50,000 image question bounding box triples. And all these triples, all these data sets, including train, test public, and test private parts, are currently available online. So you can use the QR code I show or the links I show also on the slide to download the data. So it's available on GitHub, Hugging Face Hub, Zenodo, and where is it? Okay, yeah, and on Kaggle. So yeah, it's all available. It's all open source. The same license as the subset of Coco we used. It's Creative Commons attribution. I will be really happy if you use it. And thank you so much. It was a great pleasure to be with you, and it was a great pleasure to run in this competition. Thank you.